Hello everyone. So basically we start with good morning or good afternoon, but we don't know at which time you are watching this video. So all in once with the behalf of our team, good morning, good afternoon, and also good evening also. So first of all, I would like to introduce our group. My name is Ritesh Patil, and our group members are Mr. Aditya Patil and Shrey Jagtap. And we have been assigned the topic of Diffie Hellman for this ISC. So basically, what is Diffie Hellman? Let us see that. Diffie Hellman, also called a DH, is a revolutionary key exchange protocol that allows two parties to establish a shared key for secure communication over an to establish a shared secret key for secure communication over an insecure public channel like without ever directly exchanging the key itself. This was a groundbreaking achievement in cryptography. So this was the definition for the Diffie-Hellman. So let us see the next point, the key exchange algorithms in the Diffie-Hellman. So basically there are three types of for the key exchange algorithms. First one is the key exchange algorithm means what? Key exchange algorithms are cryptography protocols that allow secure establishment of shared secret keys between parties over insecure channels. DH is a prime example, but there are others like RSA that use different mathematical foundations. So let us see the key exchange algorithms. So let us see the key exchange algorithms. So first one is the secure transmission. Secure transmission refers to the process of sending data and confidentially and with integrity over a communication channel. Key exchange algorithms like Diffie-Hellman play a crucial role in achieving secure transmission by providing the shared secret key used for encryption. Other one is second one is the encryption process. Encryption is the process of transforming data into an unreadable format using a secret key decryption. The reverse process requires the same key. So this all. And the last one is the asymmetric encryption. Each party has a public key pair, a public key known to, and a private key. Data encrypted with public key can be decrypted with the corresponding private key, making it suitable for digital signature and public key infrastructure. Russia is a popular asymmetric encryption algorithm. So let us move to the next page. Next one is the public and private keys used in the Diffie-Hellman. So let's start with the public keys. Public key means what? Public keys are widely distributed to send allow others to send encrypted messages to the key owner. Means they can be accessible by anyone, and uh, Alice and Bob agree on two publicly known values. First one means the a large prime number, and second one is a primitive root. So what is let's move to the next point. What is the private keys? Each party secretly chooses a randomly private key. When one is Alice A and Bob B. Means when there are two parties and each party will select their own their own private key. Hmm. And the third one is the key pair generation. Each entity generates a key pair consisting of a public and private key using mathematical algorithms.
Good morning, guys. Myself Aditya Patil. I will explain the topic of Diffie Hellman in secure communication. In the Diffie Hellman, key exchange is fundamental cryptographic protocol used in the secure communication to establish a secured secret key between two parties over the insured channel. The shared secret key can then be used for encryption and decryption for messages, ensuring the confidentiality. The security of the Diffie-Hellman key exchange relies to the difficulty of computing discrete logarithms in a finite field. Even if an attacker interprets the exchange values A and B, it is the completely invisible for the determine the shared secrets without knowing either A or B. In this Diffie-Hellman in secure communication, there are three types. First is shared secret. In the shared secret using Diffie-Hellman, two parties can be established a shared secret key without directly exchange it. The second type is secured handshake. The algorithm ensures that the key exchange process is secure and not vulnerable to intrusion. Third type is a confidentiality. It provides a means to create a secure channel for the exchange of sensitive information. And I will second type of explain it security vulnerabilities in Diffie-Hellman. The Diffie-Hellman key exchange protocol, while being a fundamental building block in modern cryptography, does have some vulnerabilities and weaknesses, especially when implemented without proper care. Here and some of vulnerabilities associated with the Diffie-Hellman key exchange. First type is man in the middle attacks. As mentioned earlier, one of the primary vulnerabilities of the basic Diffie-Hellman key exchange is the susceptibility to man in the middle attacks. An attacker can interrupt the exchanged public values and replace them with their own, establishing separate shared secrets with each party. This allows the attacker to decrypt and potentially modify the communication between the two parties without their knowledge. The second type is weak key generation. The security of the Diffie-Hellman key exchange relies heavily on the choice of parameters. If weak, poorly chosen parameters are used, it can make the protocol vulnerable to attack. For example, using small or non-prime values for P can lead attacks the exporting the discrete logarithm problem to more efficiency. Third type is the denial of service. In this the service, the attackers can disrupt the key exchange process and resulting in a breach of communication securely. Thank you.
Real world application in that the first point is networking. A network is two or more computers or devices that are linked in order to share information or data. Networking refers to a large set of standards and protocols that organize and regulate the sharing of information. Some of the networking protocols are TCP and UDP, HTTP for web request, DNS to convert domain names to IP addresses, IMAP, and SSH. Secure communication. A secure communication involves several components including encryption, authentication, authorization, integrity. Encryption plays a crucial role in protecting confidentiality and integrity as it is a data security control that can be applied to data when it is in all three different states of its life cycle: at rest, in transit, and in particular scenarios to data is in use. Key management. Key management is the process of putting certain standards in place to ensure the security of cryptographic keys in an organization. Key management deal with the creation, exchange, storage, deletion and refreshing of keys. They also deal with the members accessing of keys. Continuous cyber risk monitoring is a technique that automates the process of regularly examining and accessing an organization's security measures. This approach aims to help the organization discover vulnerabilities and address them before intruder exploits them. Mitigation strategies in that the first point is encryption protocol. Data encryption is a method of protecting data by encoding it in such a way that it can only be decrypted or assigned by an individual who holds the correct encryption key. When a person or entity accesses encrypted data without permission, it appears scrambled or unreadable. Data encryption is the process of converting data from a readable format to scrambled pieces of information. This is done to prevent prying from reading confidential data in transit. There are mainly two types of data encryption: symmetric and asymmetric encryption.